There are those who say, and of course it's bogus, that man-made carbon dioxide drives the climate. That's just so preposterous that I won't even address it. Because a very elementary, basic overview of geology will show you that it's just absolutely untrue. I'll leave it at that. But there are those, on the other hand, who say that the sun drives the climate. Let's go out far away from the solar system, way, way, way out in space, and look back at the little star, the little obscure, puny star around which we orbit. Let's go way, way out past the Oort cloud, the place where comets come from. Let's go way, way out into the so-called interstellar boundary. And let's keep on going, looking back at an obscure little star. NASA will tell you that this obscure little star and its planets and its asteroids and comets and so on are all enveloped inside an invisible bubble created by the sun's magnetic field and the solar wind, which are particles streaming outward from the sun. And they say that this obscure little star is moving through space, and it is encountering a cloud of interstellar gas and dust, which NASA calls the local cloud. Since our obscure little star is moving through this cloud of interstellar material, the heliosphere becomes teardrop shaped. They don't use the expression teardrop or raindrop, but they say that it is blunt on the front, rounded like the nose of a bullet, with a tail proceeding out behind it. They recently, in a press release, revealed more evidence about this tail, which before, within the past few weeks, wasn't known. But now they have evidence of a tail. The shape of the heliosphere, according to NASA, is produced by the movement of our sun moving in a certain direction. They'll even tell you which direction it's moving through this local cloud of interstellar medium. Remember, I said that there are those who say that man-made CO2 is what controls the climate, dramatically impacts the climate, and then there are those who say that the sun dramatically impacts our climate. But we're out here in space looking back at this teardrop-shaped heliosphere surrounding a little star as it moves through the interstellar medium. And lo and behold, if you look out in the rest of the nearby galaxy, you see there are some other stars that have the same appearance, like a comet. Looks like a comet, but for different reasons. I would put forth and suggest, theorize, that it is our movement through these huge clouds of interstellar gas and dust, the interstellar medium, that dramatically impact our climate. Because the temperature, space is just flat cold, but the temperature inside one of these dust clouds would be slightly warmer. And when we exit a dust cloud, the entire solar system would be enveloped in a cold, dark vacuum of nothingness, which would allow UV rays to emanate outward from the Earth's surface, be absorbed into this cold blackness of nothingness, whereas before there would be something there, a super greenhouse. This cloud of interstellar dust and gas, the local cloud, would be a super galactic greenhouse. The edges of the Earth's atmosphere would cool slightly outside of this warm by comparison, warm cloud. The upper reaches of the Earth's atmosphere would cool slightly. Eventually, the atmosphere itself would cool slightly. But before all this cooling happened, which might take a few years, ice clouds would form in the upper atmosphere. Water vapor would condense into ice. Reflective clouds of ice crystals, which would provide a positive feedback, causing further cooling due to the reflectivity of these upper level ice clouds. Maybe they're so slight you can't even see them. And maybe the temperature drop is so slight it would be hard to detect. But as centuries go on, you realize that the Earth is in a different environment and it is heading into another glacial episode, because the slight cooling produces the slight cloudiness, which blocks a slight amount of sunlight, which never reaches the Earth's surface, never warms the surface of the Earth and the oceans, and gradually and relentlessly the planet's self-regulating temperature, self-regulating water vapor content is notched down. Ice builds up on the poles, clouds increase, temperature drops, the weather is dramatically different. And as soon as our Earth re-enters a dust cloud, dramatically, this process in geologic terms, maybe it only takes a couple of thousand years, but in a couple of thousand years, suddenly the planet is warm and bright again. The ice begins to drip and the water begins to run and the rivers are filled with meltwater. And whereas Canada was covered by a mile of ice, this meltwater begins to run down the Mississippi River Valley, and eventually it recedes, the ice recedes until all the water in will become the Great Lakes begins to flow out the St. Lawrence into the North Atlantic, and then it flows and fills up into Hudson Bay and so on, and eventually the sea ice around Greenland, in between Greenland and northern Canada and Siberia at the top of the Earth, eventually becomes absent, so that you could pass through there in a wooden sailing boat. But it still varies, even though it's very slight, and most of the ice on this water on the North Pole has melted. The ice on the North Pole varies. It increases some years, it decreases, but it is significantly less than it was during the glacial episode, where it was over a mile thick. Not much happens on the opposite pole, the South Pole. It's a landmass, and that ice is stuck there. It never melts. It never gets warm enough to melt. So the sea level rise is due largely to the melting ice on the North Pole. Greenland never melts, but the glaciers atop Canada and North America, the northern United States, and glaciers on the northern part of Europe and Asia melt. Sea level varies by over 100 meters during these glacials and interglacials. And nobody really claims to understand what causes the glacial episodes, which are probably a temperature change of 10 to 15 degrees centigrade. They're worried about a 1 degree change. Everybody is obsessing over a 1 degree change, and a few inches rise in sea level, and they're oblivious to the 100-meter rise in sea level and the 10 to 15 degrees increase in temperature. It is like straining at a gnat and swallowing a camel. Suppose man just swallowed a camel for breakfast, but he cannot bring himself to swallow a gnat. Oblivious to the huge in-your-face change, in your face. But we fret and worry about some small thing that may or may not happen. And lo and behold, it's not going to happen, because human emitted CO2 is a slight increase in a trace gas that is insignificant. The major driving force of the climate, according to my theory, is what I'm trying to tell you here, is the movement of the solar system through space, passing through clouds of interstellar gas.